going to begin talking about related rates. Before I get started, I'm going to talk about some basic notation I'm going to use. V, I'm going to say is volume, C is circumference, R is radius, T is time, and A is area. So what is meant when I write each one of these? Well, when I write dV over dt, I am talking about finding the derivative of the volume with respect to time. I'm not going to write each one of these, but I'll just say them. This one would be find the derivative of the circumference with respect to time. Number 3 would be the derivative of the radius with respect to time. The fourth one, the derivative of area with respect to time. The next one, the derivative of the volume. Derivative of volume with respect to the radius. The last two that I've written here is if I find out that the volume with respect, the derivative of the volume with respect to time is a positive number, I'm going to know that it is that it's increasing. And number 7, if I find the derivative of something, in this case the derivative of the circumference with respect to time is a negative number, I'm going to know that it is decreasing. Here's the method that I'm going to use over and over again to be able to solve a related rates problems. Anytime I can draw a picture, I will, even though I'm the worst artist in the world. I'm going to make a picture for myself. I'm going to write down the given and the find. I'm going to figure out what formula is needed. Then I'm going to find the derivative. I'm going to plug in my known values, and I'm going to solve for the unknown value. I'm going to label my the correct rate or units. All right, the first example I'm going to do is a pebble is being dropped into a calm pool of water. So here's going to be the pebble that's dropped, and the ripples are going out and around, creating these circles. It says if each ripple moves out from the center at a constant rate of 1 foot per second, what rate is the total area of the disturbed water increasing at the end of 4 seconds? A lot going on. That's why we need to use that method. Step 1 was picture. Step 2 is to find the given. What are we given? And what are we trying to find? I'm going to search for what I'm given. I'm given that each ripple moves out from the center at a constant rate of 1 foot per second. Well, how would I denote that? Well, I'm talking about the radius of the circle and how the radius is changing with respect to time. And I can see that right here. 1 foot is talking about the radius, and then it's over time. So I'm talking about dr over dt. dr over dt is 1 foot per second. The next thing I have is actually the question. It says, what rate is the total area of the disturbed water increasing at the end of 4 seconds? So how is the area changing with respect to time? That's what I'm trying to find. When, this is the bar we're going to use for when the time is 4, when t is 4. So that's step number 2. I've written down the given and the find. Step 3 is figure out the formula that I need. Well, the area of a circle is area equals pi r squared. Step 4, differentiate that. We're going to differentiate this with respect to t. dA over dt, the derivative of a would just be dA over dt, is equal to 2 pi r. Remember, we're taking the derivative with respect to t, so I'm going to have dr over dt. Well, I'm trying to find where the area, what the dA over dt is when t is 4. Well, I need to plug in my known values. I only know that dr over dt is 1. Well, what is r at the end of 4 seconds? Well, remember, it's changing at 1 foot per second. So this is 4 seconds. So at the end of 4 seconds, my radius would be 4 as well. So that means my d over dt is equal to 8 pi, and that will be my final